Slide can you see? Okay. So shall I start, sir?
Yes, you can start. Now I think sufficient people have joined. Still
Okay,
more
sir.
may join. You can start the program, no problem.
Okay, sir. Good afternoon, one and all. Technology readiness levels are a method for understanding the technical maturity of a technology during its acquisition phase. TRLs allow engineers to have a consistent datum of reference for understanding technology evolution regardless of their technical background. With enormous pleasure, I welcome you all to this expert talk on process of innovation, development and technology readiness level and commercialization of lab technology and tech transfer. Now I call upon Dr. Mahima Ganeshan, President of the Institution's Innovation Council of Ahalia School of Engineering and Technology, to deliver the welcome address.
Good afternoon all. First of all, I welcome our beloved Principal and Academic Director, Ahalia Group of Institutions, Dr. P.R. Sri Mahadevan Pillai to this session. Welcome, sir. Next, I welcome our Honorable Vice Principal and Assistant Director, Ahalia Group of Institutions, Dr. Krishna Kumar Kishore to this talk. Welcome, sir. On behalf of Ahalia Institution Innovation Council, IEDC and ISTE, I welcome all the department HODs, faculties, staff members and students to this talk. Without any delay, I would like to share a brief introduction about our invited speaker, Dr. K. Lakshmi, Professor and Head, Sri Krishna College of Technology, Coimbatore. She is the convener of IIC from our mentor institution. She received her BE degree in Electrical and Electronics from Bardhan University, ME degree in Power Systems from Annamalai University, and achieved her PhD degree from Anna University, Chennai. She has over 19 years of teaching and research experience. She has published more than 40 papers in reputed international and national journals as well as conferences. She has also published 2 book chapters in Springer series and 6 books in Express and Lab Lambert academic publications. She has published 4 patents and currently guiding 10 PhD scholars under Anna University, Chennai. She is a recipient of Outstanding Woman Achiever Award from Venus International Foundation and bestowed with Best Teacher Award, Best Paper Award from International Forum. She is also a life member of ISTE and member of professional bodies like IFERP and IAENG. She has delivered many guest lectures in high voltage engineering, deregulated power system studies, and design of electrical machines in reputed forums. I welcome you, ma'am, to the session.
Thank you, Mahima ma'am. Next, I would like to welcome our principal, Dr. P.R. Sri Mahadevan Pillai, for the presidential address.
Good afternoon to all of you. Very happy to note that Dr. Lakshmi, Professor and Head of the AAA Department of Sri Krishna College of Engineering and Technology, is joining us today for a talk on process of innovation development and technology readiness. We are having a sort of MOU with the Sri Krishna College. First, we had it for the Margadarshan scheme. We have agreed to be their Mendi institution. And now for the IIC also, that mentor-mentee relation is happening. I couldn't come and meet the people there, but our vice principal and some HODs have been there. And moreover, one of our former HODs is working there itself. So we are having a close liaison with Sri Krishna College. We couldn't have much of our students to attend this program today because for one batch, university examination is going on. For the other batches, internal examination is going on, which will be, and one more thing is, as per the government and court rules, mobile is not permitted inside the college. So all the students are now in the college and we cannot officially permit them to use the mobile inside the college. So in between the classes or test purpose, it is difficult to take them to computer room and ask them to attend this session. So maybe the day chosen was so that many of our students are unable to join this. Doesn't matter, we'll have some more programs because we are having a constant liaison on each other.
Sure, sir.
And maybe Dr. Lakshmi can attend and address our students sometime later when the students are free, or on holidays our students are available for online programs, or till last week they were at home attending online classes, but since now it is offline, we have got that restriction. I'm sorry.
Yes, sir. I can understand.
That is
sure.
there. And just half an hour back, HOD was asking me whether we can permit the students to attend, one batch to attend online, because I didn't want to break the government and court rules. So though it is physically possible, we didn't go for that. But anyway, nearly 48 people, I think, have joined this, 45 or 48 have joined this. Yeah, so it is as good as a classroom right now. So because for a teacher, the motivation level comes when there are people to hear or listen. Otherwise, the class will become very sluggish and interest will be lost. But I think 40 plus is good enough as a listener group. I will be also listening to you fully. And I'm very happy that you have joined us in this program. So without much ado, I would like to wind up my presidential address. Once again, on behalf of the Ahalia School of Engineering and Technology, welcome our honorable speaker and all the attendees. Thank you. Thank you very much.
Thank you, sir. Before starting the session, there are some instructions. Any queries can be typed in the chat box. Our resource person will clear all your doubts at the end of the session. Now, without any further delay, I hand over the session to Dr. K. Lakshmi, Professor and Head of Department of Electrical and Electronics Engineering, Sri Krishna College of Technology, Coimbatore. Please, ma'am.
Very good afternoon to an adult present over here. Really, I feel great pleasure, and I would like to thank the management, principal, and heads of various departments, faculty member, and particularly IIC convener and vice president for giving this wonderful opportunity to provide to share my knowledge on this particular topic. Thank you very much for the dignitaries, and really we felt happy to be a mentor institution to the Ahalia institution, and already we had orientation session, and we had interacted with our IIC council members and principal, and always we are ready to support in all aspects. Sure, sir. It is not a ending session, and sure we will be running throughout the this IIC 4.0. Whatever the support needed from Ahalia institutions, we are always ready to provide, and this is a wonderful opportunity, and without much delay, I would like to directly go to the session. And yeah, so this particular topic, particularly why we have chosen, why they have given in the IIC process of innovation development and technology readiness level. Based on this process innovation development, then the next technology transfer and the commercialization technologies will happen. We have to kindle the young minds to develop their innovation, and the product level, design thinking level, we have to take our students to the next level. So that with that motto, I think they have chosen a very good topic, and really this topic is very good, and which will be needed for this younger generation. So they know what is the innovation from the first year onwards. The students, they have to think for the innovation. What is innovation? What it involves? How can I make? Whether I have to start with the existing system or have I build a new system. So that makes the better innovation development. I feel so. Here the innovation product development, which involves many process. We can go with the recent scenario in the current era, the digital product engineering to business innovation goals. Many students, they have an opportunity to develop their software skills, and not only these soft skills, they can produce, they can develop their hardware components too for the real-time applications, for the societal applications. So that gives a transformation from the young minds to innovative ideas in the real-time picture. Here, we need all the activities involved in turning concept like a new, better user experience into real world products. The earlier days, the people might have many disadvantages. They could not have the much idea, or they could not have take the data, but nowadays, which is very easiest thing. I think everybody knows about the Bill Gates. He believes always in the innovation that provides the most powerful force for change in the world. People who are pessimistic about the future, they will tend to extrapolate from the present in a straight line. But the innovation that fundamentally shifts the trajectory of the development, it is not be a straight line. Always they are in the trajectory mode. So, madam, is the slide is getting changed?
Yes, ma'am.
Yeah. Thank you, ma'am. Here the why the innovation, every people we are thinking the innovation startups as per our Prime Minister Modi ji. He expected earlier days, we have to the many company people, they are providing the opportunities to the young minds. But why we have to work under, you can't start your own innovation idea. That's the startup this for developing more startups, incubation centers, this innovation development in the college level, that is most essential factor nowadays. So here the primary benefit of innovation product development is accelerating the process by which any innovative idea that could be transformed into effective design and development into the marketable and innovative products. Yeah, I will show the case study and what are all the idea behind it, what are the ways and everything. I will show it. And during the presentation, the students or any faculty members, those who are having doubts, you can post your queries in the chat box, and or else at the end of the session, I will clear the all your queries too. And here the innovation is underway, so we have to grab the opportunities. We should have every institution, not only the other research centers. Nowadays it is comes to the undergraduate level, UG students also, they have to. So we are in a position, we engineering organization, we have to move towards innovation as a goal, one of our goal, into innovation underway. So we can facilitate a shift paradigm in culture to one of sustainable and ongoing innovation. So here in this innovation, we need the motivation, then creativity and uniqueness and the technology. So many factors are involving how we are grabbing and how we are working on a particular problem. It may be an existing problem. If there is a simple solution, yes, we can able to develop. And or else if you are having a new idea, yes, we can develop. So all these comes under the design thinking and innovation development. Before going to the innovation development, I wish to explore some of the essential skills which would be required for the idea generation. Yeah, I don't have any idea. How can I make it? So some students might think it is not a worrying factor. Yeah, you can have your normal, regular day-to-day activities in the academic or the regular activities. You can think what are the possible ways. So storyboarding, or it may be of puzzles kind, or the mind mapping, or the word banking, or the word scrambling, or what is it? Then the gap filling, whether I can go with the gap filling, and why you can analyze. For example, the strength of a system, weakness of a system, and what are the opportunities in a particular system, and what are the threats for the system. So you can make this analysis. Sure, you will find any idea, many idea. Actually, this innovation development, the idea generation might come in one mind, but the real-time implementation and the development will make a team formulation. Then the brainstorming session we can have, and regularly we have to give brainstorming session to the students. Then they will have enough, as many as ideas, and where they have to work. And from these, the questioning assumptions and role storming, and the, yeah, always we have to use the social media too. We can use the social media in a effective and positive ways. So not only these essential skills, there are a scamper. Yeah. So what is the, whether it is an alternative or substitute, or able to combine the two ideas, or two or more ideas, the electrical core engineering and the computer stream. Nowadays the computer stream is booming, so able to make the interdisciplinary idea generation, that gives more valuable, and that gives many innovations, and the adaptability, and also the magnification. So how we can, as much as magnification development is in the idea generation, that will going to the next level. So therefore we could able to put the other uses, not only for, even though we have generated an idea to a single application, that can be magnified to the many multifunctions, and we can eliminate some unwanted that ideas also. We can keep it in the reserve, and if needed, yes, we can. So the most essential skills required for this innovation development is idea generation. This scamper idea, I think the rearrangement. So after writing all those, so we will make a rearrangement, we will have a complete idea, then that will be more useful, and the students, young minds, they will be moving towards the innovation development process. First they have to fix their goal, where they want to be, and what are the developments possible, and what are the improvements possible, and what are the possible solutions. So all those things they have to discuss, and here they could develop the students through this innovation development. The students able to develop their the interpersonal skills and communication skills, and they could able to lead a team leadership qualities and teamwork qualities they can improve. Recently, the MHRD, MOE, Ministry of Education, they have launched the SIH problem statements. So sure, we can involve as many as students. They can pick the problem statements on healthcare or agriculture or medical field, and we will nurture the students' young minds to give their solution. Then we will formulate a team, and then we can lead to the innovation development and product development, I feel. And how the two poles, expenses and profit, and income and tax, likewise we should have always a progress curve, and we have to analyze where we are lagging, where we are leading, and what are the threats and what are the opportunities. Everything should be analyzed. Then the innovation process, it will be in the right path. And here the make it, we have to first, from the idea generation to how we are making in the launching. With the video also, I will embed, I would like to enhance the video also to 5-minute video. So through the video, always the people thinking about the picture oriented explanation, picture oriented demonstration, that will attract the young minds. They will develop their idea skills and innovation process. So from the idea generation, how they are defining, how they are starting from the scratch, they will combining, and they can able to test it, then able to design and test both the things happen together. After completing the entire product designing and testing, then it will be going for the branding, commercialization, and the people, the students, they will go for the commercialization. They have to need the business plan and the fund product, how the product to be funded, how it could be protected, and what are the IPR. Here it will cover all the area. Once the student, they have developed the prototype, how it could be copyrighted, and we will involve the students in the patent publications. Then finally, after getting copyrighted, it will be commercialized and it will be launched to the real-time society. Yeah, I would like to show this video.
You have an idea for an awesome new product. You know how many you can sell per year and at what price. And you've started putting together a budget for the upfront design and production costs. How do you take your idea and make it a reality? First, you'll need to write out your wish list in as much detail as possible. Make sure to prioritize by putting key features at the top. Now you can begin sketching out your initial idea and further refine your wish list. Once you're happy with your sketch and have determined the product's core
Ma'am, sorry to
functionality,
interrupt.
you'll need to team up with industrial designers and
Ma'am, Lakshmi
engineers.
ma'am.
The industrial designers work on the product's look and feel and ergonomics. The engineers work on the functionality within. Both teams will have questions and will bring up any concerns about your wish list. Now that the functionality of the product has been fully determined, the designers and engineers are ready to move forward. The designers begin sketching ideas and planning for the case.
Gopika ma'am, is the video is visible?
Ma'am, only the audio is visible now. Video is visible.
Yeah, sorry.
You know how many you can sell per year and at what price. And you've started putting together a budget for the upfront design and production costs. How do you take your idea and make it a reality? First, you'll need to write out your wish list in as much detail as possible. Make sure to prioritize by putting key features at
This wish list is most essential for the idea generation. Based on this wish list only, we could develop the many innovations.
the top. Now you can begin sketching out your initial idea and further refine your wish list. Once you're happy with your sketch and have determined the product's core functionality, you'll need to team up with industrial designers and engineers. The industrial designers work on the product's look and feel and ergonomics. The engineers work on the functionality within. Both teams will have questions and will bring up any concerns about your wish list. Now that the functionality of the product has been fully determined, the designers and engineers are ready to move forward.
Yeah, for every idea generation, this is the most important thing is questions. We have to ask as many as questions within us. How many are being produced, and what is the required battery life, and how much storage space for any this for a simple case study to produce the product development. Likewise, for each and every idea, so what is the expected timeline, what is the waterproof, whether it need to be waterproof. Likewise, many questions, each and every young mind, they have to have as many as questions we have to. If you are having writing, if you are having questions, then more idea, more product will be developed.
The designers begin sketching ideas and planning for the case design. Engineers begin by creating a proof of concept using off-the-shelf development kits and ready-made modules. Any risky components are identified and tackled first. Next, the engineers need to create a schematic. During this phase, we incorporate all the components required to meet the specifications, while keeping best practices for manufacturing and testing in mind. Once the schematic is finalized, we begin creating the alpha PCB layout. Up front, we'll determine the layer count for the board, optimizing the balance between cost and performance. The alpha is a
It is not audible now.
Lakshmi ma'am.
Ma'am, is it
It's not
audible?
audible.
Ma'am?
Ma'am, it's not audible, ma'am.
Oh, I will check my side. Please 1 minute.
You have an idea for an awesome new product. You know how many you can sell per year. You have an idea for an awesome new product. Within. Forward. Engineer identified and tackled first. During this phase, we incorporate while keeping best practicing out the PCB layout. Upfront, we'll determine the layer count for the board, optimizing the balance between cost and performance. The alpha is the first revision of the design that will be built. Alpha boards are usually larger to facilitate field changes, and they often include lots of
Gopika ma'am, is it audible now?
Yes, ma'am. Now it is audible.
Yeah, sorry for the inconvenience.
extras like test points and debug headers for troubleshooting. When the alpha design is complete,
Yeah, here. After making the product, the testing part is so essential. Being an engineer, we have to test the product before commercialization. So here, the most important critical part, and the being a mentor faculty, we can involve and we can guide them, and where the troubleshooting and the issues happening, and what are the possible practical issues that will be sorted out and before commercialization. So here the students will get struggle, where the faculty members, we could guide them properly, and the students, they could able to develop the trouble-free product.
the engineers will send the design files to a PCB assembly house for fabrication. Prototype board fabrication can be a lengthy process, typically taking 2 to 4 weeks. Depending on your product timeline, it can be expedited down to around 1 week for an additional cost. When the boards arrive, engineers carefully apply power and begin running electrical tests and executing test code. Each engineer gets a board they can then use for development and testing. The designers also receive a board to see if their enclosure needs any design refinements. Once the engineering and design team are happy with the initial development, they'll send you a working prototype. This part is highly collaborative. There will be lots of web meetings, making minor adjustments, and planning for the final design. Once you're happy with all the new design ideas, the engineers incorporate them. After a revision or two, you now have a fully functioning beta prototype. Depending on your product, the next step may be to send it to various test labs like UL to get approvals. The engineers can help guide you through this phase. They can also connect you with a volume manufacturer to produce it. If you're ordering a high volume,
As I said, though we have started with a single application, after during the product development process, during the process of the entire product development, we might have the multifunctionality, and we can discuss, and wherever possible, yes, this product can be used, and the extensive use of the product will be increasing. So that will also enhancing this development process.
you may need a production calibration or test switch to create it. Now your product is in the user's hand and we've made your idea a reality.
Thank you. I think through this simple video, the participants, you can easily understand the significance of how we can start the development process. So, as I said, what are the core questions and the application questions for any product development? What will be the problem you want for giving a solution? So for which problem, whether you are starting with the existing problem, already it is there, and you can extend and you can give additional solution or enhancing the product, or else whether you are going to give a new product, a new idea or new design, new system. So there are the many kinds of people, groups, and organization may have the same problem, and how many are there, and where they are, and what they are doing about it now, about this problem, and how it is different from your idea, and who are the competing with this field, and how they are different, the competitors, and how we can able to make money, and what are the chances, how will the investors make money, and all the questions, how can we grow as a business, so whether we can able to scale up without proportional scaling up headcount, or shall we start with the prototype model, then we can go for the scaling up. So there are so many questions, as many as questions if the student is having, the innovator is having, then definitely they will go for a new innovative product, and they always, their mind should says, and immediately they have to write whatever the questions arising in their mind. Immediately they have to write, and they have to make a picture, and they have to discuss with the people, and they could able to come up with a new idea. And why did you decide to do something to the society, or the marketing, or to the financial decision? So whatever it may be, we need some always objections related to the market, competition, financial plans, the business plan. Being a student level, it is very tough. During that time, we can have the for example, computer science students, they he or she wish to develop his own website. What are the HTML, what are the basic skills he need, and he have to develop, and whether it is for which kind of applications, whether it is the industry or agriculture or medicinal or any other applications. Then while developing the business plan, they can take the help of the MBA students. So than the engineering students, here we can involve the MBA, most of business administration students. They can give better business plan than us. So likewise, we can take the interdisciplinary, and who are the investors, and how strong is your patent, and whether we can grow faster with more money. And we have to realize whether the underestimating the market expenses, or the sales expenses, or the marginal prices, or the channels, everything. So this the core questions and the follow-up questions are always throughout till their commercialization. Even after commercialization, what will be the next level? So always the questioning, and writing, and thinking, and developing is most essential in this innovation development. So far we have discussed the what the idea generation, what is the innovation development. So we are having many technology ideas, everything, but how it could be transferred as a commercialization, as an incubation, as a startup. So that technology readiness level is a very kind of essential thing, and it should be tested. Sometimes there is the technology readiness level must be tested with the skilled persons. We need, so far we no need of any skilled person, but at this technology readiness level, definitely we need the specialized person for whether it is the up to the mark. The technology readiness levels are a type of measurement system which is used to assess the maturity level of particular technology, and each technology project is evaluated against as many as parameters for each technology level, and which will be assigned a TRL rating based on the project progress. So that's why I have told this TRL rating is especially we need the trained people, and that people, they will be rating the how your technology is applicable to the real-time system, and whether your project will able to meet out these technology level. So before going to meet out the TRL, the expected TRL, we should know what are the levels in the TRL, technology readiness level. So actually there are basically 9 levels of technology readiness are there. These 9 levels are originally developed by NASA in the year 1980s. So in the level 1, basic principles observed and reported, then concept and application formulated, then how we are able to demonstrate analytically or experimentally, then what are the key elements are involving in the laboratory environment, then what are the key elements involving in the relevant environments, and the desirable, the representative of the deliverable demonstrated, and the higher levels 6, 7, 8, 9 or the normally the 7, 8, 9 or the very higher level. So where the final development version and the actual deliverable, whether we will be able to qualify through, and the operational use of deliverables. So up to 6. Without these skilled persons also, we could able to analyze the technology readiness level, but the to meet out the 7, 8, 9, we need the always that the basic level, applied level, and the prototype level. So here, how the technology readiness level, which will launch the preparatory program in future, and what are the levels we could able to basic research, the level 1 and 2. Or the basic research, we have to do lot many literatures, and we have to utilize the social media applications. What are the literatures available, what is the existing nationally, internationally, everything, basic principles observed, and the complete research we have to have in the first and second level. After finalizing the technology, that has to be pushed to the concept studies, where the whether the gap is met out from the invent and the application. There is an gap, the level 3, 4, 5, 6 bridge the gap between the research and the real-time development. Therefore, this the third level and fourth, fifth, sixth level, we have to spend much time to bridge the gap, and then we will be going for the 7, 8, 9. That is the higher level, and where the system pull to the real-time development. So here there are NASA, actually they launched this 9 levels. And the same also, I have the pre-game changers. For example, game changer funding also. The another example, game changer funding. So what is the pre-level basic research? Then that for the game changing, we don't want to 1 and 2. Only one first level is enough. But for the next proof of concept, we need more levels up to 2 to 6. So how the basic research is moved to the next feasibility, whether the game changing is feasibility, and the limitations and benefits and the real-time demonstrations, everything is possible. That will be analyzed during the second level to sixth level. Then finally the corporate level, while we are implementing the game changer in the corporate level, so we need the subsystems development and the testing and the launching of operations. Yeah, here I think now you have been enriched with the various 9 levels of technology readiness levels, the basic principles, technology concept, critical functions, or it may be proof of concept, maybe the analytical model, mathematical model, or it may be experimental work also. Then laboratory testing, and laboratory testing, there are 2 kinds. One is in the process type itself, or the complete integrated system, then the verification or testing, then for the complete demonstration and commercial and full-scale deployment. And here, here the NASA technology readiness level, the TR1, where the basic principles observed, and TR2, technology concept or application, how it is formulated, and then the technology TR level 3, concept of application proven, and the TR level 4, the basic prototype is validated in laboratory equipment, laboratory environment, then in the real-time environment, and then in the system subsystem also to be demonstrated. Then in the level 7, the demonstrated in the relevant environment, then finally the test and demonstration, and the ninth level will be in the successful operation actual system, how whether it is proven. So in this manner they have developed, and now coming to the commercialization. As per the idea generation, and whether we have met out the all the TRL levels, technology readiness level, after that only we will be going for the commercialization of the lab technologies, scaling up. The technology commercialization is the process of transitioning the technologies from the research lab to the marketplace. So where in this commercialization, the interdisciplinary team working all accompanying and accomplished in many ways through educating students, publishing results of research, and ensuring the inventions are developed into useful product, and is there the possibility before the commercialization, the innovation must be copyrighted, then the much problem can be avoided. Here the commercialization of lab technologies or in the various levels, in the research levels, then the disclosure of the protection, then licensing also very much essential nowadays for the, we know the how we are getting the approval from the government, and that process also to be gone through with the students. And then integration and collaboration, testing and validation, then final product development, and the manufacture and the deployment in the real-time industries. So in this manner, the students actually, this commercialization is very difficult for the UG students. So that's why I have given an idea during this time, this business plan and the commercialization master MBA students, they can, if they were in this team, sure, definitely they will be able to, UG students, they will be reaching for the commercialization of their own innovative products. And commercializing new technologies by enhancing the talents, how the entrepreneurs we are making, as much as entrepreneurs, there are the cooperative research development agreements, or the ER programs, that is entrepreneur in residence program or entrepreneurial leave programs. So there are opportunities are there. The public as well as the private entrepreneurial partnership also is nowadays they are encouraging. Then visiting some scientist programs and educational partnership agreements we can able to make. So these commercialization, exchanging talent and commercialization the new technologies. So all the students during their 4 years of study, they have developed in the first 2 years. They should have in the first year and second year, the students can make as many as idea generation. At the end of second year itself, they can start the process of involving. In the third year completely, they could able to make products and everything. At the end of third year, they can go for the commercialization, and they will be going through the commercialization. Then sure, we will have as many as incubation centers and entrepreneurs in our campus before they are leaving the campus. So all these commercialization of technologies to be explored to the student, how the product from the lab, research lab to the market. So that exposure, here the innovation, then invention disclosure, then IPR, as I said, the copyright. Once we have the idea generation, and immediately is the idea generation to be patented, then the experimentally, after completing the complete prototype, after testing and evaluation, then again we will be going for the examination, then the through the IPR, intellectual property filing, and the commercialization assessment. So after that only we could able to start a company and find a partner. If so, and we could able to negotiate for the real time. We have to negotiate the license and the follow up support for from the various resources from the public and society. So in this way, sure, definitely students will be an entrepreneur. So here, this is the commercialization of lab technologies, how we are making out from the roots. So as I said, the first year, second year, all the process, they have to do the idea generation, everything. Here the faculty role is also much essential, and the infrastructure, the university or the college, we have to provide the infrastructure to the students, exclusive laboratory, and then the federal funding also, if possible, we could able to provide. Then collaborations with existing small industries or small startups, we could able to collaborate initially. Then we can start our lab technologies to the real-time commercial product. And throughout this, from the root to the real-time fruit, we need the guidance from the faculty members, so that the product demonstration, everything. So this commercialization, I think the students, they could able to understand the process. And the technology transfer, idea generation, the TRL, technology readiness level, and then we are moving to the commercialization. Then now the technology transfer, and this technology transfer is the movement of data, designs, inventions, materials, software, technical knowledge, or the trade secrets from one organization to another, or from one purpose to another. We should not take one person to another, one purpose to another purpose, or one application to many applications. That we have to always think, and technology transfer, that should be guided properly, and the policy making, the procedures and regulations, and the implementations, the values of each organization, that has to be involved in this technology transfer. I think due to the time constraints, I don't want to showcase the video this relevant to the technology transfer. So just I'd like to showcase. Ma'am, is it okay, or shall I continue?
Yes, ma'am, it's okay.
Yeah. So here the technology transfer, everywhere we are using, how we are making the digital payments, so that DigiLocker, digital money, everything. The recent budget proposal also, they are going to launch soon, the DigiCoin also. So for everything, the technology, with the help of the technology transfer only, this is possible. Here earlier days, the people are telling that IoT. Nowadays, the people are telling that transfer of technology. So that will replace many things. Actually, this will be happening. The technology transfer will be happening between the universities, business, and governments. And actually, this started from the educational institutions. So where the technology, how the technology will be transferred, and what are the, whether it is formally or informally, how we are sharing the skills, technologies, and manufacturing methods to the society. This form of knowledge transfer helps ensure the scientific and technological developments to wider range of users. Really, they can develop and exploit it. I hope so. And there are a few processes also, likewise, the TRL, the various levels in the technology readiness and the commercialization. Here, the technology transfer and the commercialization process also there. So it will starts with the innovation, the basic idea generation. So that starts with innovation, then the disclosure, then the evaluation, testing, and the fabrication, everything. So then the protection through the copyright, then it will be commercialized through marketing, then we will be going for the real-time commercial product development, commercialization, whether it may be the industry or public or people. So here also there are the technology transfer, everything. Earlier is how we have a big computer, and nowadays we are having a simple system. So that I could showcase in the simple animation also. Everything always So the books has been eliminated, the drawings has been eliminated, the printer, everything, paper, all the things we will be having in our single mobile also. So how the technology is being very simple example. And the future commercialization technology is also there. That is the skull systems and blah blah cow, then Andela, then Magic Leap, then Markerboard, Oculus. So many commercialization technologies are available even now and in future also. So everything, the people are thinking that we never think nowadays the electric car, the conventional vehicle has been soon that will be vanished, that will be obsolete, and so more e-vehicles and Instacart also will be there, and Fuel 3D, and there are many apps, Slack, Facebook at work also, then exit round, VR pop-up. So many commercialization technologies or many startup companies are there. So earlier days also the students, they want to go for reputed industries, but nowadays the people are preferring for the startups. Why? They could able to learn the basic skills and they can develop their skills. So if you're starting your own startup, if you want to become an entrepreneur, sure, definitely these ideas, this presentation will help. In the based on that, the some future project ideas also I can be explored. The lab made dairy products, then digital pens that track their health. Yeah, nowadays also we can install many apps in our mobile and we can follow up. Then green funnels, artificial eyes, yeah, it will be soon it will be launched. Then app codes for drones and flying taxis, then smart switches that detect the infections, energy storing bricks. So many project ideas are there. We could the sweat covered smart watches and self-healing living concrete and living robots, already it is there. Tactile virtual reality, yes, the virtual reality concepts, the artificial intelligence, machine learning, and cyber security. There are so many computer deployment is there, but the applications there, the core area that definitely needs many applications in the core area. The heart monitoring t-shirt, then drown forest fires and sound, and then self-driving trucks and floating forms. So many project ideas. Likewise, I could able to explore, and the students, you have to pick whenever you are hearing a new word, immediately you can able to Google it and you can find out and you can make a literature whether this idea is, when it has been generated, whether it was there, whether it was implemented. Immediately the students have to search and what are the modifications can be done, what are the limitations, what are the benefits, what are the demerits for each and every system. So likewise we have to do analysis, then the modifications or new idea can be developed. I think I have covered as per the topic given. So thank you very much for giving me the opportunity, and thank you very much for all the members, dignitaries, for the patient listening. And I request any queries. Yes, please.
Thank you, ma'am, for that extremely informative session. Now I welcome our principal, Dr. P.R. Sri Mahadevan Pillai, to hand over the virtual memento to Dr. Lakshmi.
I happily hand over the virtual memento to Dr. Lakshmi,
Ma'am,
our guest of honor for the day.
ma'am, could you
Thank you,
please
sir.
stop sharing your screen?
Ma'am?
Could you please stop sharing your screen?
Yeah.
I request you to receive it on behalf of us.
Thank you, sir. Thank you very much for your token of love. Sure. I hope this session was very much useful to the students.
Yeah, you are most welcome to visit our campus when the COVID is over. This
Sure,
is the
sir.
largest campus in Kerala with so many academic institutions and healthcare institutions. Please do visit it.
Definitely.
All right.
Definitely, sir.
Thank you, sir. Thank you, ma'am. Now it's time for the Q&A session. If anybody has any queries, it can be typed in the chat box. Lakshmi ma'am will be answering your questions. Now we have a question, ma'am. What is role storming?
Yeah, it is a kind of the role playing, the brainstorming session. Actually, we have to give a role, any kind of role to the students. How, while we are making the initial stage of idea generation, this role storming is very much useful. For example, if you want to, because being an electrical engineer, always I could able to not able always my mind says the electrical idea. So while we are having idea to generate e-vehicle or battery system, immediately, so what are the possible whether there are many batteries, lithium-ion batteries or the lead-acid batteries or any kind, so which one we have to select, and we have to give for each and every role, and we have to pick the merits and the limitations, and the student have to analyze the all the benefits and limitations. Then that will help the idea generation, aids the idea generation.
Thank you, ma'am. If anybody has any more questions? Okay, ma'am. I think we are done with the questions. So now now I welcome Mr. Danesh, the Vice President of IIC ASET, for the vote of thanks.
Am I audible?
Yes, sir.
Yeah. So on behalf of IIC cell of Ahalia School of Technology, I would like to express my sincere thanks to Dr. K. Lakshmi, Professor and Head of EEE, Sri Krishna College of Technology, for giving such informative session on innovation development and technology readiness level. Thank you, ma'am. I would also like to thank our respected principal and vice principal for the constant support in promoting such informative session. Thank you, sir. I would like to express my gratitude to the team of IIC headed by Dr. Mahima, President IIC, for arranging such informative session. Last but not least, I'd like to express my sincere thanks to all the participants for their keen participation for the event. So once again, I express my sincere thanks. Thank you.
Thank you, sir. I request all the participants to fill the feedback form in order to get your certificates. And I thank everyone for being with us today. Thank you all. Thank you all for participating.
Thank you, ma'am, for joining.
Yeah, thank you. Thank you, ma'am. Thank you, sir. Thank you all.
Thank you for joining, ma'am. Thank you so much.
Thank you. Thank you very much. Thank you.